Hello, everyone. This our fifth experiment. This is about how hydraulic bench circulate and operate. The hydraulic bench is a volumetric flow measurement apparatus that consists of a water receptacle present at the bottom, through which water is pumped up to an open channel through a control valve by a centrifugal pump. This water is finally discharged into the volumetric tank, and the change in level of water in the volumetric tank, as given by the calibrated scale, gives the flow rate. The hydraulic bench diagram shows the general working or functioning of the water supply. The water is stored in a sump tank. When the motor is turned on, this water is pumped up to the open channel through a suction pipe, which is kept transparent to identify the onset of the cavitation process. In case it commences, this open channel is the water source for the volumetric hydraulic bench tank, and therefore, the water flows from the channel to the tank present at a relatively lower elevation. Finally, this water is made to outflow the tank back into the reservoir or sump tank. To operate a hydraulic bench, first make sure that the water tank is filled with enough clean water. Check if all hoses and connections are properly attached to avoid any leaks. Next, turn on the pump so that water starts flowing through the system. You can control how fast the water flows by turning the flow control valve. Set up the equipment you need for your experiment, like a weir, nozzle, or flow meter, and make sure it is placed securely on the bench. While the water is running, take note of important readings such as the flow rate, water level, and pressure. When you are done with your experiment, turn off the pump and slowly close the valve. Lastly, drain the water, clean the bench, and return all equipment to its proper place to keep it ready for the next user. By using the hydraulic bench, we can learn and measure many things about how water behaves in different situations. It helps us find the flow rate, which tells us how much water passes through a point in a certain time. We can also study how water pressure and head change when water flows over weirs, through orifices, or around bends. This helps us understand important principles like energy conservation and fluid dynamics in a simple and clear way. During the experiment, we can practice taking accurate readings and learn how to use measuring tools properly. We also get to observe how changing the flow rate affects the water level and speed. This experiment gives us hands-on experience in applying hydraulic theories we learn in class. By using the bench, we improve our skills in data collection, analysis, and problem solving. It also helps us see how hydraulic systems work in real-life situations like dams, pipes, and canals. Overall, the hydraulic bench is a useful tool for learning the basics of fluid mechanics and preparing us for real engineering applications. This is the recording of first and second trial. In the first trial of the experiment, the initial volume of water was 2 liters and the final volume reached 15 liters, giving a registered volume of 13 liters. The time it took for the water to flow was recorded as 63.12 seconds. Using these values, the flow rate was calculated to be 0.206 liters per second. This shows that the water flowed at a steady but slightly slower rate compared to the other trials. In the second trial, the initial and final volumes remained the same, but the time recorded was 60.92 seconds, which is shorter than in the first trial. Because the time was shorter while the same amount of water flowed, the flow rate increased slightly to 0.213 liters per second. This means that the water flowed faster during the second trial, possibly due to small changes in valve opening or water pressure. Comparing the two trials helps us understand how time directly affects the flow rate. The shorter the time for the same volume, the higher the flow rate. These measurements show the importance of accuracy in timing and water volume when working with the hydraulic bench. Overall, both trials give useful data that help in analyzing the consistency and reliability of the flow system in hydraulic experiments. This is the recording for third and fourth trial. In the third trial, the initial volume was 2 liters and the final volume reached 15 liters, giving a registered volume of 13 liters, just like the previous trials. The time recorded for this experiment was 61.05 seconds, which resulted in a flow rate of 0.213 liters per second. This flow rate is the same as in the second trial, showing that the water flow was steady and consistent under similar conditions. In the fourth trial, the same initial and final volumes were used, but the recorded time was slightly longer at 61.71 seconds. Because of this small increase in time, the flow rate decreased a bit to 0.211 liters per second. The difference between these two trials may have been caused by slight variations in water pressure or manual timing during measurement. These results show how even a small change in time can slightly affect the calculated flow rate. It also highlights the importance of careful observation and accurate timing during hydraulic bench experiments. Overall, both trials demonstrate that the system maintains a nearly uniform flow, proving that the setup was properly controlled and functioning well. This is the recording of fifth and sixth trial. In the fifth trial, the initial volume of water was 2 liters and the final volume reached 15 liters, giving a registered volume of 13 liters. The recorded time for this trial was 61.74 seconds, which resulted in a flow rate of 0.211 liters per second. This value is very close to the previous trial, showing that the water flow was stable and consistent. In the sixth trial, the same initial and final volumes were used, but the time recorded was a bit longer at 63.30 seconds. Because it took more time for the same amount of water to flow, the flow rate slightly decreased to 0.206 liters per second. This small change shows that longer flow times lead to lower flow rates, which is expected in hydraulic experiments. The results also suggest that minor adjustments in the valve opening or slight timing differences can affect the readings. These two trials help confirm the accuracy and reliability of the earlier results by showing similar trends. They also demonstrate that consistent data collection is important to reduce errors. Overall, the fifth and sixth trials support the experiment's goal of understanding how time and volume affect the flow rate in a hydraulic bench setup. And that wraps up the manual that we used for the hydraulic bench in the laboratory. Through this experiment, we were able to explore how water flows through a system and how its movement can be measured using time, volume, and flow rate. We learned to observe how the water level rises in the volumetric tank and to record how long it takes for a certain volume to fill, which allowed us to calculate the flow rate accurately. Using the control valve, we adjusted the flow and saw how it affected the rate at which water passed through the setup. We also became familiar with the parts of the hydraulic bench, such as the sump tank, volumetric tank, flow control valve, and the pump, and how they all work together to keep the system running smoothly. By conducting several trials, we noticed that even small changes in valve openings or timing can slightly affect the results, showing how sensitive fluid systems are to adjustments. We also learned how to properly handle and maintain the equipment, turning on the pump carefully, ensuring there are no leaks, managing the water level, and draining the system properly after each use. This experiment taught us not only about flow measurement but also about the importance of consistency, coordination, and teamwork in performing laboratory procedures. We gained a deeper understanding of hydraulic principles such as conservation of mass, energy, and momentum, which are essential in designing systems like pipes, dams, and irrigation channels. The hydraulic bench made it easier for us to see how the theories we study in fluid mechanics apply to real situations. It helped us develop technical skills in reading measurement. That's it, guys. Thank you for watching our video. Once again, we are the Group 1, and we are glad to share this knowledge that we experienced in real life. Bye-bye.